Alright, welcome back to my YouTube channel, and in this episode we are going to continue by loading the structural members. So in this episode I'm going to start with that of Prota structure software. Remember, we are still trying to compare the analysis, design and detailing results of Prota structure software with robot structural analysis software. So let's continue. So we stopped here in the last episode. So in this episode we are going to load the structural members. So I'm going to start by loading the beams at the first floor. Alright, I will go to plan. This is the plan view. So I will go to beams. So I'm going to start by loading the beams. Remember, in our architectural floor plan, we don't have wall loads on these inner beams. On these inner beams we don't have wall loads on them. We only have wall loads on the external beams. Also we have partition walls on some of the slabs at the first floor. So we're going to start by loading these external floor beams. So let's start. So I'm going to pick this external beam, right click, then go to edit wall load. Then the wall unit weight I'm going to use 3.47, and the wall height, since our beam is 450 millimeter and our floor to floor height is 3 meter, so therefore the wall load is going to be 3000 minus 450. So our wall height is going to be 2.55. So I write we type 2.55. Then the wall thickness is 0.23. so that gives a dead load of 8.85 kilonewton per meter. So I'll click OK. So I can easily transfer this load to the other beams. So I'll just right click and go to copy wall load. I will hold down my control key while I select the other external beams. Okay, I have selected all the other external beams. Then I will right click, then I will paste the copied beam loads. Yes, so now I have the wall loads on other beams. We can have a look at it in 3D. So this is what we have done so far. So I will go back to plan, and remember in the last episode we have partition walls on some of the slabs. So I'm going to start by editing the additional dead load on each panel. So let's go to panel 2. Let's go to panel 2. Panel 2 says the additional dead load is 3.99. Actually the additional dead load from the partition is 1.99, but I assumed 2 kilonewton per meter square for finishes. So when you add these two to 1.99, you have 3.99. So on panel 2 now, I will just, this is panel 2, I will go to properties and go to loads. Then I will, instead of 2 here, I will now have 3.99. So that is 2.1.9, 2 plus 1.99. So I will now have 3.99 kilonewton per meter square. So I will update, then close. Then for this panel, we have, for this panel, that's panel 4, we have 5.68. 5.68. That's panel 4, we have 5.68. So I will go here and say properties, then load. I will type 5.68 kilonewton per meter square. So update, then close. And for this panel, I will go to properties under load. That's panel 5, and the loading there is 7.23. So I will just edit this as 7.23 kilonewton per meter square. Update, then close. Now for this panel, we have, this is panel 6, and on panel 6 we have 5.81. So I will go to panel 6, properties, then go to load. We have 5.81. So I will change this to 5.81. Then I will update and close. Then which other panel? We have panel 8. What do we have on panel 8? We have 4.15. 4.15. So I will change this to 4.15. Update, then close. Then which other one? Panel 12. What do we have on panel 12? We have 3.89. 3.89 on panel 12. 3.89. 3.89. So I will update, then close. Then for this other panel, what do we have? That's panel 13. We have 5.09. 5.09. So I will edit this to 5.09. Update, close. Then which other one? So let's go to panel 16. Panel 16, we have 6.66. 6.66. So we come here. Sorry, 6.66. That's this. Excuse me. Sorry, panel 13. Have we done for panel 13? Panel 13 is 5.09. Okay, we have done for panel 13. So for this other one, that's panel 16, we have 6.66. 6.66. So we change this to 6.66. We update, then we close. Then this last one, that's panel 19, and we have 5.97. 5.97. Properties, loads, 5.97. So we update, then we close. Alright, so now we have loaded the slabs. Now we are also going to load the roof beams. So we go to story 2 where we have the roof beams. So on the roof beam we are going to add the roof live load and the roof dead load. So for the roof live load we are going to take it as 1 kilonewton per meter square, and for the both the roof dead load and the roof live load, so both of them are going to be 1 kilonewton per meter square each. So I will just select the first beam. I will go to edit member loads, go to finite element, new load, then this. So the dead load for the roof I'm going to use 1 kilonewton per meter, while the live load I'm going to use 1 kilonewton per meter. So we click OK, then OK. Alright, so I'm going to copy this to the other beams. So I'll select this first beam again and right click, go to copy manual loads, then scroll down, hold your shift key and select the last beam. Then all the beams will be selected like this. Then you right click and go to paste copied beam loads. Yes, now all the roof beams are loaded with a live load of 1 kilonewton per meter and a dead load of 1 kilonewton per meter. So the next thing we will do now is to also load the roof beams with walls, parapet walls. So I'm going to select one of the beams that is applicable. So I will just go to edit wall load, then the wall unit width remains 3.47, while the wall height this time around is going to be just 1 meter. Wall thickness remains 0.23. So okay, now we can copy this load to the other beams that are applicable. So we go to copy wall load, hold your control key and select the other beams that are applicable. So I'm selecting the beams that are applicable. Alright, so my intention is to have walls on these beams like this, just like this. So the water from on the roof is expected to flow to this other side. So now I'm going to right click and paste copied beam loads. Yes, so now we can have a look in 3D like this. Alright, now we are done loading the structural members. This lesson is not going to take into account the loading from the staircase, but in other episodes on my YouTube channel I'm going to do something on that. But for this episode, for this training that is going on, the comparison between Prota structure software and robots, I'm not going to model the staircase, and we're just going to base our analysis, our comparison on this simple model. So now I am done loading the structural members. So the next thing is to analyze the structure. So the what we are going to do next is we go to analysis, building analysis. Under the building analysis, we edit the materials. So for the grade of concrete, we can just select one, make it let's make it 25/30, apply. Then you apply to all the members of this material class, then you okay it, and everything we take the same value. So for the steel, let's make use of we can use 410, 460, 500. I'll just leave it as 500. Apply, then okay. So for the columns, for the column rebars, I'm going to select on select. Then let me take 16. Let me take 20. Then okay. For the, we don't have any wall, any concrete wall, so we just go to concrete beam. Let's select 16 and 20 as well. Okay. So for the slab, let's select 12. Okay. Then for the links, let's select 10, 8. Okay. So we click OK. Or sorry, for the foundations, we can make it 16, 20. Okay. Then for the links, make it 10, make it 12, make it 8. Sorry, make it 8 and 10. Okay. Alright, so now we go to project parameters. Our design is based on this Eurocode 2, that's for concrete design code. So for the foundations, let's assume the foundation is 70 kilonewton per meter square. Then I'm going to leave all these as default. I'm going to apply notional loads on the story levels, so I'm going to leave this. So the title, we can just edit the title. There's a proposed, let's say proposed development for Mr. Charles, then made by, you can just put your name, engineer Michael, checked by, you can put the name of your superior, maybe checked by engineer Lou, and the project number, let's say this 2022. Let's just put something like this. Project date, let's put it like this. Alright, so we just click OK. Then under the loading combinations, I'm going to generate the loading. So I'm going to just leave this as default, except I'm going to change this to 1.35. Alright, so for the horizontal loads, I'm going to include the wind loading. So I will click OK, and these are my loading combinations. So now I will click OK. Then I'm going to generate the wind load. We can go to wind load calculator, and the basic wind speed I'm going to leave. I'm going to make it 20 for this training, 20 meter per second. Then I'm going to leave every other thing as default. Apply. Then we can expand the story, so we can see the forces at each story, the wind forces. Then I click OK. Then under the model option, I'm going to make this 25%, then make a flange section. Then shear wall model, I'm going to leave it like this. Then I'm going to use the composed slab and rip loads. My stories, I'm going to include the column section in finite element model. Then I'm going to change this to use the composed beam loads. Then the next thing is to analyze. But before I run the analysis, I'm going to close this first. I will go to loading. Then I will go to load the composition by FE. That's finite element. Then I'm going to run the analysis here first. So I go to this area. Okay, continue. All right, it's running. All right, so we click OK, then we close this and apply to all the beams in the model. So we can now go back to analysis, building analysis. Then you can as well check your building model. You can check in case you have any error. So number of errors 0. So we close this. Then we go to building analysis, column design, beam design. You can reselect the steel bar in case the ones selected are not enough. So we just go to building analysis. So we wait while the building analysis is ongoing. Alright, column reinforcement design. Column reinforcement design is ongoing. Then beam reinforcement design. Alright, so the building analysis is completed successfully, and the relative story drift satisfies the limit. Okay, so we close this. We close this. Then we close this. Alright, so now we are through with the analysis, and let's go and check the design. Story beams. Okay, all the beams passed. Let's just have a look at one of the beams. Alright, so okay, so we close this. What of the columns? We go to columns. Let's expand it. Alright, all the columns passed. Okay, so we can close this. Now let's pick a column as a case study. We're going to compare the axial load on this column with that of the one in Prota, with that of the one in robot software. So let's pick this column, for instance. This is 1C10, and let us note the position of this column, so that when we do the same, when we run the analysis in robot software, we will be able to compare the axial loads on this same column in robot software. So let's note this column and let's have a look at the axial load. Let's go back to plan, and let's select the first story 1. Let's go to story 00. So let us go and check. So we go to display, we go to visual interrogation, column display, axial load. Then let us select all the loading combinations. Alright, so these are the loading combinations. So we click OK. Then we have this. So these are our case study 1C10, and these are the loads according to different loading combinations. For the combination 1, we have 265.9 kilonewton. For this combination 2, we have 251.9 kilonewton. So we have the maximum to be, let's have a look. What is the maximum value? 271.22. all right, so the maximum value here is 271.2 kilonewton. So if I were you, I would note this value. I'm writing it down, 271.2 kilonewton. Now we are done with the analysis, and this is our case study. Or let's have another column we are going to use as a case study. This is 1C9, and let's take the maximum value here. The maximum value here is 268.5. so the first one is 1C10 and the second one is 1C9. For 1C9 we have 268.5 kilonewton. all right, so now we are picking these two columns as our case study. So now we are done with the analysis in Prota structure, so we go to robot software. So now we go to robot software. So this is robot structural analysis professional. So in the same way, we are going to be loading the structural members. In the last episode, I made a mistake of modeling slab in the staircase area, so I'm going to delete the slab in the staircase area. Delete. Alright, so now we are going to be loading the structural members, and I'm going to start by providing support for these ground floor columns before we now start loading the structural members. So I'm going to provide a support like this. You click on support. We're going to be providing a fixed support. Fixed. Then we highlight the columns. Then I will click on apply. Alright, so now we have support for the columns. Now to load the structural members, we'll change from geometry to loads. So under load, I'm going to start by adding the self weight of the structural members first, that is DL1. So DL1 is the self weight of the structural members, so I will click on add. You can see all the structural members are highlighted. Then DL2 is going to be for additional dead loads, so I will click on add. Also, we're going to have a live load, add. Also, we have a wind load, click on add. Alright, so now we're going to load the structural members. We can extend this one. Alright, so now we are going to start by loading the structural members. First of all, the same way we did in Prota structure, we're going to start by loading the panels with additional dead load. So we start with this panel 2. So this is panel 2. Now make sure you change from wind load to dead load 2. Dead load 1 is for the self weight of the structural members. So we go to dead load 2 for the additional dead loads. So I will click on panel 2, and I will now go to load definition. Under load definition, I will go to surface. So now under surface, I will click on uniform planner. So I will now enter the additional load. Now what is the additional load? The additional load is 3.99. So I will enter minus 3.99. So you click on add, then you apply it to the selected panel. Apply, close. Now to see the load value, you can right click, go to display, then under load you select load value, then OK. Now this is the value of the load we applied on the slab. So now the next one is panel 4. Panel 4 is sorry, let me close this folder. Alright, so panel 4 is 5.68. 5.68. So we click on panel 4, then we go back here, surface, then we change this to minus 5.68. Add, then apply. So close again. Here we have 7.23, 7.23. So we change this one to minus 7.23. So you add, apply, close. Then for this we have 5.81 minus 5.81. Add, apply, close. Then for this we have 4.15. So we change this one to minus 4.15. Add, apply, sorry, 4.15. sorry, I need to change this. Okay, let's take it again. So I will select the panel, then we come here, then we go to surface, so minus 4.15 hard. Oh, sorry, let me delete. Alright, so we take it again. Surface minus 4.15 hard, then apply, close. Alright, so the next panel here is panel 12, and panel 12 says 3.89. This is panel 12. 3.89. So we change this to minus 3.89. So you add, then you apply, close. Then the next one is 5.09, which is this panel. 5.09. So we write minus 5.09. Let's confirm. 5.09. That's panel 13. Panel 13, 5.09. Okay. Add, then apply, close. Then the next one is 6.66. 6.66. That's panel 16. Panel 16 is 6.66. Alright, so this panel 6.66. So we go to 6.66, add, then apply, close. Then the last one we have 5.97. 5.97, that's panel 19. 5.97, that's this panel. 5.97. Add, then apply, close. Now we have added the additional dead loads on some of the slabs. Now we are going to add the wall loads. First of all, we're going to add that of the external floor beams, the same way we did in Prota structure. Remember, our internal floor beams, they don't have wall loads. Most of them do not have wall loads. So now we're going to load the external floor beams. So we can just click on a beam, we right click and go to select similar by cross section. All of them will be selected, so we don't want all of them to be selected. That's why we need to select them one by one. So we select one like this, sorry, escape, select one, then hold the control key and select, sorry, mistake, make sure you are selecting only the beams. Hold the control key and select only the beams that are applicable, so you don't pick the wrong beam. I'm going to rotate the model. Alright, so I will hold the control key and select the other beams. Alright, I have selected all the beams that are applicable. Now I will go to load definition, but this time around I will go to bar load, that is element load parameters. Go to bar load, so you go to uniform load, then I will add the wall load. I'm going to use exactly the value of the load we got in Prota structure for the external beams. So I'm going to use, we are trying to compare the analysis, so we have to use the same loading throughout. So I'm going to use the value of the loading is 8.85, so we use minus 8.85 kilonewton per meter. So I will click on add. Then all the beams are already selected and they are here. This is the identity for all the selected beams, so I will click on apply, then close. Alright, now for the roof beams, I'm going to apply the roof dead load on the roof beams. So I'm going to select just a beam. I will right click and go to select similar and select by cross section, and all the roof beams will be selected. So I will now go to load definition, bar load. So I will add another uniform load, which is the dead load of the roof, which I'm going to use the same value as I used in Prota structure, that is minus 1, that is 1 kilonewton per meter. So I will click on add. Then all the roof beams have been selected, so I will click on apply. Then we have the load here, close. So now the next loading we are going to apply is live load. So I will change this from DL2 to LL1. So under live load, I'm going to apply the live loads on the slabs first. So I will select one slab and go to select similar by thickness. Alright, so now I will go to load definition, surface, then I will apply a live load of 1.5, add, then we apply to the selected slabs, apply, close. Alright, so that is the live load on the floor, on the slabs. So in the same way, I'm going to apply live load, that is the roof, live load on the roof beams. So I'm going to just the same way I did in Prota structure. So I will go to I will just select a beam and go to select similar by cross section. Then I will go back to load definition, bar load, uniform load, then -1, then add, apply. Alright, close. If I don't want to show all these load values, I can just come here and select A. Also load symbol, I can just click here, then it will go. Alright, so now we go back to additional dead load. I forgot to add the wall load on the the parapet wall load on these external beams. So we are going to do that now by selecting these beams. Alright, after carefully selecting the beams that would support the parapet wall, so I will just go to load definition, bar load. I will add a new load, and the value of the load is exactly what we used in Prota structure, that's 3.47. So I will click on add, then apply, close. Alright, now I have added all the loads to the structural members except the wind load. Now for the wind load, this is how we go about it. First of all, let me do this. Alright, so for the wind load, we are going to model cladding to cover all the openings in the model. So we go to geometry, we go to claddings, select rectangle, and make sure your load distribution pattern is two-way. So now we're going to carefully model cladding and let it cover all the openings. Right, this is one. Sorry, I'm trying to rotate the structure so that I will not go and just to avoid mistakes. So geometry, go to claddings, select rectangle, alright, close. Now let me rotate this very well. Alright, so go to claddings, rectangle, close. Okay, alright, this is correct. So for this part, I go to geometry, claddings, rectangle, this, okay, close. Alright, so go to claddings, rectangle, here, and this point. Alright, so we are left with two areas now. Alright, so I go back to claddings, rectangle, I will select this point, and this point. Close. Let's have a look. Alright, so this is the last point. So we go to geometry, claddings, rectangle, then this point. Alright, so now finally we have this point, then close. Now we have done we are through with the modeling of the claddings. So let's have a look very well. Alright, so now the next thing we are going to do now is we are going to go to loads, then you go to wind loads simulation. So you go to generate wind loads. So now here we select y minus, that is the wind direction, y plus, and the x plus. These are the wind directions. Now for the wind velocity, I will leave it as default, just the same value we used in Prota structure, 20 meters per second, and I will leave the wind pressure value as default like this. And wind exposure, so already all the elements are selected, so I'm going to delete this selection, and I will now select all the claddings. So I will just select one cladding and right click, go to select similar by thickness. Now all the claddings have been selected, so I will now copy the list from here. This is the list of the claddings 151 to 158. So I will just Ctrl C, come to here and Ctrl V. So you have the same thing here, 151 to 158, 151 to 158. That is only the claddings. So now we go to start. So the wind simulation is ongoing, and this would take an average of let's say 5 to 7 minutes. So we wait until we complete the wind simulation. The wind simulation is still ongoing, and now is on the y plus direction. Alright, the wind simulation is almost done. We are on the y negative direction. Alright, the wind simulation is complete. Then we can close this. Just say okay. Then we can close this. Alright, now we are going to do the loading combination. You can see the load types for the different directions have been generated: x plus, y plus, x minus, y minus. Now we're going to do a loading combination for all these loads. So we go to loads, then you go to combination table. Under the combination table, you go to edit, then you right click, then you go to table columns, then you select the analysis type, then you click OK, and at the same time you can right click and you can reduce the number of these columns. It's quite long. You can reduce it from 40 to, let's say, 4. Okay, so we have 1, 2, 3, 4 load cases. I think our maximum load case is 4 dead load, 2 dead loads, 1 live load, and 1 wind load. That's 4. So we are good. So now for the first one, we go choose the analysis type to be linear combination, and the first load case is dead load 1, and the factor of safety is going to be 1.35. Then the dead load 2, same thing, factor of safety 1.35. Then the third one is live load. The factor of safety we use 1.5, and the last one is the wind load. So now we select wind, the wind simulation, and that's 5, and we use factor of safety of 1.5. So for the next one, again we take load case 1, 1.35, load case 2, 1.35, load case 3, 1.5. Then this time around we go for 6, that is wind simulation y plus, then we use 1.5. again load case 1, 1.35, load case 2, 1.35, load case 3, 1.5. then you go for 7, that is x minus, then we use 1.5. then for this linear combination, load case 1, 1.35, load case 2, 1.35, load case 3, 1.5. then here we select hit, then 1.5 as a factor of safety. And lastly, we will have this combination, load case 1, 1.35, load case 2, 1.35, then load case 3, 1.5. we will not add any wind load. So we are done. We can remove this. So we are done. We have we go to value, and we see that we have 1, 2, 3, 4, 5 load cases. So we have 5 load cases. Now we can change this to geometry, so we can come back to this interface. Now if you click here, you will see that we have our load cases, combination 1, 2, 3, 4, 5. Now we can also check the load value under the load table. You will see the different loads here. So let's go back to the geometry and let us analyze the structure. So to analyze, we just go to calculations and the structure will be analyzed. Alright, you can see results, finite elements available. Now the analysis is complete. I will just go to the analysis results, go to diagram for bars, then under this I will go to reaction, then I will go to, I want to check the axial loads for the different columns, so normalize, and then we have this. This is our case study, this column and this other column. This is our case study, or we can pick all the columns as our case study just to compare between the axial loads that we have in robot structural analysis and that of Prota structure. And this we are going to do in the next episode. We are going to be comparing, maybe we can pick 1 or 2 beams as well and compare the results. We can check the moments and all that, and this we are going to be doing in the next episode. Thank you very much for watching, and please don't forget to subscribe to my YouTube channel. See you again in the next episode. Bye.